In this video, we are going to solve 2005 AP Calculus AB FRQ Question Form B. It says a water tank at Camp Newton holds 1,200 gallons of water at time t equals 0. Okay, so that's the initial amount. That's pretty important. During the time interval between t is between 0 and 18 hours, water is pumped into the tank at the rate W of t, which is a tongue twister down there. During the same interval, water is removed from the tank at the rate R of t, which is also right here. So let me put an arrow there so we can see where they are. So this is a rate removed. This is a rate of it entering. Is the amount of water in the tank increasing at time t equals 15? Why or why not? That's pretty easy. So if you want to know if it's increasing or decreasing, you got to figure out W of 15 and R of 15. This is probably the hardest thing, plugging into the calculator with all the parentheses. So it might be easier to do it individually than subtract them. So W15 minus R15. I did it all together on the calculator, but it took me about a minute or so to figure out where the parentheses are. On TI-89, you have to put the parentheses around the entire sign, including the t divided by 6, and then square that part. So when you solve this, you get negative 121.09. Now, is this increasing or decreasing? This is less than 0, so the water is decreasing. Let me write that down. Okay, next part, part B. To the nearest whole number, how many gallons of water are in the tank at time t equals 18? Okay, so this one's pretty easy, but you can't forget the 1,200. So you got to do 1,200 plus figure out how much water is entering and leaving. So you do 0 to 18. W of t minus R of t dt, which when you solve will give you about 1,309.788. And what are the units? Gallons, because it's gallons per hour. Okay, so you could say 1,310 gallons, because it wants to know to the nearest whole number. Okay. Part C. At what time t for 0 is less than or equal to t, which is less than or equal to 18, is the amount of water in the tank at an absolute minimum? Show the work that leads to your conclusion. So we need to find where the rates equal 0. So what I did is I graphed it and I actually looked for it. The only problem is they want you to include your endpoints. So you would do W of t minus R of t equals 0, which t is approximately equaling 0 at the following locations: 6.495 and 12.975. So now we need to include our endpoints. So we need to write down at 0, t equals 0. How many gallons are there? There's 1,200 gallons. At t equals 6.495, you're going to have to integrate, and you're going to have to do the same thing that you did over here, but use a 6.4945, and you're going to get 525 gallons. And now you're going to have to do the same thing for the 12.975, which is the max, or at least according to the graph. When I did it, I saw that the slope was positive. And I got 1,697 gallons. And then the last one, T of 18, which was the 1,310 gallons. So the minimum is going to be the smallest one of these, which is right here, which you could kind of tell if you looked at your graph. The function or the rates being subtracted from one another was going in a decreasing direction. So it was kind of doing something like this. The graph was, let me just zoom out so we could see it. And let me move this so it's not an issue. So when I did it, the graph of the rates was something like this. So I knew right there this was the minimum because I had a lot of negative distance, and at 0 it was traveling in downward direction. Okay, part D. Okay, let me zoom in a little bit. So part D says, for T is greater than 18, no water is pumped into the tank, but water continues to be removed at the rate R of T until the tank becomes empty. Okay, let K be the time at which the tank becomes empty. Write but do not solve in an equation involving an integral expression that can be used to find the value of K. Okay, so what's going to be important is this guy right here. This is how much water is in at 18. So we know it's greater than 18. So we got to put 18 down here. We're going to put K up here. And now we know water is being removed. So we're going to do R of T dt. And it has to equal 1,310 gallons. And that should solve everything. Okay, I hope this video helped. And please check out our next video.